To graph the square root function, step 1. Anticipate the graph using transformations from the parent function f of x equals the square root of x to the new function. Step 2. Set the radical expression greater than or equal to 0 and solve for x to find the domain. Step 3. Choose 3 values in the domain that will give you perfect squares under the radical. Use a t-chart or table to find the function values. Step 4. Plot the points and graph. Here we're going to graph the function g of x equals the square root of x plus 2 minus 1. So the transformations, if we have our parent function, we just do a horizontal shift left 2 units and then a vertical shift down 1 unit. Our domain would be x plus 2, so we do the radicand here, set that greater or equal to 0, solve for x, and we see our domain is negative 2 to positive infinity. Then we can pick a couple points just to be able to graph them out. So when we have x of negative 2, we have a g of x value of negative 1. When x is negative 1, our g of x is at 0. And when x is 2, we have a g of x value of 1. So our graph looks something like that. We could also take our parent function, which would be here and then there. And you can see that's the parent function in red. All we've done is horizontally shifted 2 units to the left and then vertically down 1. And there we have the parent function in red and our new function g of x in black. Now let's graph the function h of x equals the square root of negative 1/2 x plus 1. The transformations from the parent function would be a horizontal stretch with a factor of 1/2, a reflection about the y-axis because of this negative sign here, and a vertical shift up 1 unit. So if we set negative 1/2 x greater or equal to 0, and then we see that x has to be less than or equal to 0. So we have some points here. If we choose 0, negative 2, and negative 8, we can graph our new function h of x. Let's graph the function j of x equals the square root of 2x minus 8. The transformations from the parent function will be a horizontal shift 8 units to the right and a horizontal shrink with a factor of 2. If we solve for the domain, we see that x has to be greater than or equal to 4. And we can pick some points, and we see this is our new graph right here. So we've shifted over to the right horizontally, and we have shrunk with a factor of 2. Now let's graph the function k of x equals negative square root of 2x plus 1 minus 2. Alright, so we have a horizontal shift 1 unit to the left. We have a horizontal shrink with a factor of 2. We have a reflection about the x-axis because of this negative sign, and we have a vertical shift down 2 units. The domain is x that is greater or equal to negative 0.5, and here we can graph out some points, and we see that we flip it over the x-axis and it points downwards like this. Graph the function p of x equals negative 2 times the square root of 4 minus 2x plus 3. Let's go through all the transformations, and there are a lot here. So we have the horizontal shift 4 units to the left, then the horizontal shrink with a factor of 2, a vertical stretch with a factor of 2, reflections about the x and y-axis, because we have both of these negative signs, and a vertical shift up 3 units. So when we plug in some numbers, after we find the domain is x is less than or equal to 2, plug in some numbers, and we see our new function p of x here in purple.